All right, so why projective geometry? And we're going to show you some of the math. All right, so what is the geometric intuition of using homogeneous coordinates? Well, basically, the idea is that we're going from a ray in space is mapped to a point in the image. So here you see a ray that intersects the image plane at z equals 1. And the idea is that every point xy, so every point xy on the image plane at z equals 1 is represented by this ray. So you see this ray here, right? And it intersects the image plane at xy1, but any point on this ray, sx, sy, s, would intersect the, when projected through the center of projection, would intersect the image plane at the same location. And that's what it means to be projectively similar. Okay, and that's the relationship between sort of these rays and the points in the image. So we already know about sort of going between homogeneous coordinates and regular coordinates. So in 2D, for example, we take a 2D point, xy, to make it homogeneous, we just add a 1 to it and become a homogeneous coordinate. That last coordinate can be thought of as the thing that tells you about the scale. So when you go from homogeneous coordinates to regular, you just divide by that scale value. That's what's shown here. But homogeneous coordinates actually allow us to do a lot more. In particular, they're going to give us a natural way of thinking about lines. And this time we mean two-dimensional lines. So here we have our standard equation for a two-dimensional line, ax plus by plus c equals 0. And what's nice is in homogeneous coordinates, it can be thought of as just this dot product essentially, right? It's ABC transpose times xy1, or I should say multiplied by xy1. And when you think of the line that way, A, B, and C can just be thought of as being the component of the unit vector in the direction of the normal between the origin and the line, and then every point on that line, when you dot it with that normal, has to be a distance d away, so that would be minus d. But the thing to think about also is it's saying that the normal, ABC, is perpendicular to the point xy1, or to the ray that defines xy1. So what's this deal having to do with perpendicularity? Get that out in one word, all right? And in fact, this perpendicular relationship is key to using projective geometry to define our points and lines.